Hey everybody, let's do a problem with a set of pliers. Now pliers, they have moving parts, and so it's possible that I could open and close these jaws, right? And so these are considered machines because of the moving parts. And what we want to do is a problem where I'm going to squeeze on the pliers, and I've got a quarter inside of here, and I want to look at the forces exerted on the quarter if I'm squeezing with a known amount of force on the handles of the pliers. And so I'm going to measure from the bolt right here. This is a pin joint, right? That center section is a pin, down to here, and that's where I'm applying the force, right? And so I can measure that out, and I've already done that. It's about 7 inches. And then from the pin here to where the coin is, or the center of the coin, in this direction, right? So from the pin to the center of the coin, that's about 1.5 inches. And then I've also measured this angle. So this angle compared to that, and I measured that out at about 45 degrees. All right, so there's a pair of pliers, and let's go ahead and solve for the forces acting on the coin. All right, so when I do that, I'm going to draw a diagram, something like that right there. Okay, so there's the pliers acting on the coin, and what I want to do is I want to separate out the one of the sets of the pliers, right? So the pliers, there's 2 parts, right? There's the left part here, the right part here, or in this diagram, it would be the bottom jaw or the top jaw. All right, it doesn't matter which one I choose. I'm going to choose one of those and start to look at the forces on that. All right, so let's choose the bottom jaw here. So I'm going to redraw this. So it looks something like that. Okay, and then I've got a force here, and I designate, let's give it a value. Let's say I can do that with a value of 50 pounds. And then there's forces right here at the pin. So I'll label that P for the pin. And so there's an X force and a Y force acting at the pin. Okay? All right, so there's those. And then there's going to be, the coin is going to exert a force. I mean, the pliers are exerting a force, a normal force on the coin. And that's what I'm interested in. What's the force exerted on the coin? So that would be a normal force due to the pliers acting on the coin. But I'm doing a force diagram on the pliers, and so Newton's third law says there's a normal force due to the coin acting on the pliers, and they're going to have the same exact value. All right, and so that's going to be a normal force. This is maybe not the best of drawings, so let me alter my drawing there a little bit. Something like that. It's not a great drawing either, but there's going to be a normal force, and I'll just call that N. And this angle is going to be 45 degrees. Okay, so it's actually the complement of 45, which is 45. So at any rate, there's the force diagram for the lower jaw. Now I have 1, 2, 3 unknowns, 1 known. So I need 3 equations. Well, that's no problem, because what I'm going to do then is I've broken the machine down into its different components. For more complicated machines, you might do more components. But for this one, I just have 2. And I don't need to do both of them because they're both exactly the same as far as the force diagrams are going to go. And so what do I have? I have the sum of the forces in the x, and that's going to be P sub x plus n cosine 45 degrees equals 0. I don't know n, I don't know P sub x. Clearly P sub x is in the wrong direction, but that's okay. The math will get my minus signs out. And then sum of the forces in the y, I have P sub y minus n sine 45 degrees minus 50 pounds. And that's equal to 0. So there's 2 equations, but I have 3 unknowns. That's okay. I'm ready to go with that. I've got the sum of the force, or sum of the moments, and I'm going to sum the moments around P, just because it makes my life a lot easier. And let's see, I need, well, all right, so it's 7 inches to the 50 pounds. So that's going to be 50 pounds times 7 inches. And that's going to be a clockwise moment. And so there's a minus sign there. And then the normal force is going to give me a counterclockwise moment. But from here to here is 1.5 inches. And then it's perpendicular to that. So it's a counterclockwise moment. So it's plus n times 1.5 inches. And that's equal to 0. So I can solve this out for the normal force immediately, and then substitute it back into this equation and this equation, and I can get piece of x and piece of y. All right, so it's pretty simple. Some machines, like I said, more complicated than this one, but the trick is, or the procedure, really isn't a trick, the procedure is to look at the whole and then break it down into its pieces, down to the different parts of the machine, the different members. Like we did with trusses, we have members. Well, here I've got 2 members. They are not 2 force members. They're definitely not. This is a 3 force member. So it's more like a frame in that aspect. But you break it down into its members, and then you look at the forces and the moments acting on each member. You might have to do several members before you have enough equations. Much like we did in the previous video on frames, we needed a lot of equations. Not a lot, but we needed a set of equations before we were able to figure out what each of the individual forces was going to be. All right, same idea here. So that's the machine. All right, if you have any questions on how to work machines, leave them in the comments below. Thank you.